Okay, so good evening. So today we will discuss this problem. Prove that a simple graph with n vertices must be connected if it has more than n minus 1 into n minus 2 by 2 edges. Okay, so what is given the question? G is a simple graph with n vertices. Okay, so G is connected. Okay, G is connected if G has more than n minus 1 into n minus 2 by 2 edges. Okay, before going to solve this problem, first we will check for n equal to 4. So I'll take 4 vertices. Okay, n equal to 4 means you'll get what? N minus 1 is 3, n minus 2 is what? 2. So 6 by 2 is what? 3 edges we need. So 1, 2, 3. So, if G has more than n minus 1 into n minus 2 by 2, for in this case it is what? 3. If it is 3 edges, then the G is what? Connected. Okay, so now we are going to solve this problem. Let G be a simple graph with more than n minus 1 into n minus 2 by 2 edges. Actually, we need to prove G is connected, but by contrary, we are assuming what? G is not connected. So finally, we'll get some contradiction, okay, and then we will say the graph G is what? Connected. So actually, the contradiction is we are going to get the contradiction here in this part. So what is the assumption? G has what? More than n minus 1 by n minus 1 into n minus 2 by 2 edges. Suppose under this assumption, suppose G is connected, not connected. Okay, so finally we will get G has less than n minus 1 into n minus 2 by 2 edges. That is a contradiction to the assumption. So and hence we will say what? G is what? Connected. This is the idea. So now, if it is G is not connected means, so it has at least two components. Okay, G has at least what? Two components. For example, I'll take the first component is uh, okay G1. This is G1. This is what? G2. Assume this is G1 and G2. So it may have more than two components also. So I will take two components. So the number of okay, select any one of the component of G. Let V1 be the vertex set of that component. So in G1, V1 is what? Vertex set. Similarly, in G2, V2 is the vertex set. Okay. So V2 is equal to total number of vertices minus V1. The number of vertices in what? V1. So that is what? The number of vertices in what? V2. Okay. Now I will take the number of vertices, that is the cardinality of V1. So in G1, how many vertices you have? M vertices. M vertices. Similarly, total number of vertices is what? N. So in G1, it has M vertices means G2 has N minus M vertices. Okay. Since the number of vertices in G is what? N. Okay. So now, first one, this M, the number of vertices in G1 is minimum 1, maximum is what? N minus 1. Because total number of vertices is what? N. If suppose if all the vertices are here means the graph is connected. Okay. That's why the number of vertices in the first component is what? Uh, Minimum 1, maximum n minus 1. Similarly, the number of vertices in the second component, okay, what is the number of vertices in the second component? N minus m. So here also you can say it is what? They are telling minimum 1. This is also what? Maximum what? N minus 1, but they told only it is minimum 1. Okay, okay, but but we should know maximum what? Minimum 1, maximum n minus 1. Okay. And then third one, there is no edge joining a vertex of V1 and a vertex of V2. So because it is disconnected, there is no edge between what? A vertex of V1 and what? Vertex of V2. Okay. Now next, okay, now the total number of edges in G. Okay, what is the total number of edges in G? The number of edges in G1 plus the number of edges in what? G2. So that is here they wrote. So the total number of edges in G is equal to number of edges in first component, the number of edges in the second component. So we know that the maximum number of edges, suppose a graph with n vertices have how many edges maximum? N into n minus 1 by 2. So this is already we know that. So here the first component has how many vertices? M vertices. So maximum number of edges in the first component is what? M into m minus 1 by 2. Similarly, the second component G2 has n minus m vertices. So the maximum number of edges in the second component is what? N minus m into n minus m minus 1 by 2. So using this idea. Now I'll take 1 by 2 common. Okay, so m into m minus 1 plus n minus m into what? N minus m minus 1. Okay, up to this I explained. Next, 1 by 2 m square minus m, and then from here to here I'll take this n and multiply these two. Okay, so yeah, I'll take this n. I'll take this n into, within bracket I'll put what? N minus 1. So still I need to multiply this n with what? This minus m. So minus n. Okay, so next minus m into the remaining everything. Minus m into what? N minus m minus 1. Okay. Next step, 1 by 2 m square minus m plus n into n minus 1. Next, I am add and subtract. So this is a crucial step. Okay. So here I am add and what? Here add and subtract these two terms because I need this one. So minus 2 into n minus 1 plus 2 into n minus 1. Okay, I explained up to this plus n into n minus 1. Here add and subtract. Next what? Minus nm minus m into what? N minus m minus 1. Okay. Next step, 1 by 2 m square minus m plus, from these two terms, okay, these two terms, what is common? N minus 1 is common. If I take n minus 1, what is remaining? N minus 2. So n minus 1 into n minus 2. Okay. Plus 2 into n minus 1. Okay. Next, minus nm minus m into n minus m minus 1. Okay. I explained up to this step also. Next, from here to here, 1 by 2. First, I am writing this term. N minus 1 into n minus 2 is here, plus m square minus m. Next, plus 2n minus 2 minus nm minus mn plus m square plus m. Okay. So here minus m plus m gets cancelled. Remaining is what? Equal to 1 by 2 into n minus 1 into n minus 2. Okay. And next, m square plus m square, 2m square minus 2 plus 2n. Here minus mn, here minus mn. So minus 2. Actually, here mn is not visible. Maybe I will write here. Okay. Minus 2. Okay, minus 2 plus 2n 2m square I wrote, minus 2 I wrote, so plus 2n minus minus mn minus mn minus 2 mn. Okay, the next step, Okay, but the left hand side is what? The number of edges in G. Okay, so the next step is what? 1 by 2, n minus 1 into n minus 2. Okay, n minus 1 into n minus 2. From this, what is common? 2 is common. So 2 into m square minus 1, 2 into m square minus 1. Next, here what is common? 2n is common. If I take 2n, you'll get what? 1 minus m. Okay, if I take common 2n, 1 minus 2m. Okay, if I take 2n common, 1 minus m. Okay, it's 2n common now, 1 minus m is correct. Okay. So now from here to here, there is no change in the first term. That's why I will because from here to here, the first term there is no change. So I explained up to this term 1 by 2 n minus 1 into n minus 2. Okay. Now I'm here. I'll write 2 into m square minus 1. I'll write what? M plus 1 into m minus 1. From this, I'll take minus common. So minus 2n into what? Minus 2n into m minus 1. Okay, from these two term, what is common? 2 into m minus 1 common. So remaining is what? M plus 1. M plus 1. If I took 2 into m minus 1, remaining here what? Minus n. So, okay, now from this, I will take minus outside. So minus, if I take common what? Minus 2 into m minus 1 into n minus m minus 1. But this is greater than equal to 0. Which one is greater than equal to 0? This is also greater than equal to 0 because m is what? Minimum, I told what? M is minimum what? 1. Okay, so m is minimum 1. Similarly, n minus 1. Okay, so n minus 1 is greater than equal to m. N minus 1 is greater than or equal to what? M. Okay, or m is less than or equal to what? N minus 1. Okay, m is what? Less than or equal to n minus 1. So minimum, okay, you can put what? M is greater than or equal to 1. Okay, so that's why this is also what? A greater than or equal to 0. Since another condition is what? N minus 1 is what? Greater than or equal to what? M. So n minus 1 is greater than or equal to m means what is the meaning? So n minus m minus 1 is what? Greater than or equal to 0. So that means this is also what? Greater than or equal to 0. So both the terms are greater than or equal to 0. Okay. But here have what? Okay, negative sign. But actually is what I want to tell is this quantity is positive. Which quantity is m minus 1? Okay, 2 into, okay, 2 into, here I can't put greater than equal to 0 because this is positive, here this is a negative sign. I mean that this quantity is positive. Which one? M minus 1 into n minus m minus 1 is what? Greater than equal to 0. So actually I mean this one. Here I can't put greater than equal to 0. Okay. So now this is a positive quantity I am telling. Okay. So look at here 1 by 2 into n minus 1 into n minus 2. Okay, this is first term. If I simplify this term, I am getting what? Minus 2 into m minus 1 into n minus m minus 1. Okay, so since this term is, okay, even if you include 2, okay, here, okay, or you can write only what? M minus 1 into what? N minus m minus 1 is positive. Okay, if I remove the positive, here it is positive, but here you have what? Sign is what? Minus. So, and hence this is totally, this is what? Less than or equal to 1 by 2 into what? N minus 1 into n minus 2. For example, if you take 100 minus 50, okay, so 100 minus 50, okay, but here logically can't tell like this, okay, but the idea is, okay, this is a positive quantity, Okay, if I remove a positive quantity from this equation, okay, this should be what? Okay, not this. The entire expression, okay, the entire expression is what? Less than or equal to this expression. Okay, 1 by 2 into what? N minus 1 into n minus 2. Okay, so actually the left hand side is nothing but what is the left hand side again? The number of edges. Okay, so the number of edges in G, that is the left hand side. Okay, so the number of edges is what? Maximum we are telling what? N minus 1 into n minus 2. So which is a contradiction. Why it is a contradiction? We assumed what? We assumed G has more than what? N minus 1 into n minus 2 by 2 edges. But because of G is not connected, we assumed G is not connected. Now we got what? The number of edges is what? Less than or equal to n minus 1 into n minus 2 by 2 edges. So which is a contradiction. So, okay, which is contradiction. As G has what? More than n minus 1 into n minus 2 by 2 edges. So why we got this contradiction? Because we assumed G is what? Not connected. So that's why we are getting a contradiction. So therefore G should be what? Connected. So that's all. The problem is over. So I'll stop here. The remaining thing we'll discuss tomorrow. Thank you.